To communicate that aqueous solutions of sodium chloride and silver nitrate react, we write NaClAq plus AgNO3AQ followed by an arrow. The addition sign means two solutions are added together, and the arrow means that the solutions may react to form products. On mixing, will these two solutions produce a precipitate? One way we could find out would be to actually do the experiment. Another way would be to consult a set of rules called solubility rules to determine if a precipitate is formed. Solubility rules indicate whether a substance dissolves in water, making it soluble, or does not dissolve in water, making it insoluble. If a product is insoluble, it forms a solid called a precipitate. When we mix aqueous sodium chloride and silver nitrate, what ions are present? Na positive sodium ions, Cl negative chloride ions, Ag positive silver ions, and NO3 negative nitrate ions. We can write our product prediction, but at this point we still don't know whether a precipitate forms. We know that sodium chloride is soluble in water. Would sodium ions attract silver ions or nitrate ions? Since opposite charges attract, perhaps the positive sodium ion will attract the negative nitrate ion, while the negative chloride ion might attract the positive silver ion. Would a positive sodium ion be attracted to a positive silver ion, or would a negative chloride ion be attracted to a negative nitrate ion? No. Like charges repel each other and do not attract. The products based on this logic are sodium nitrate and silver chloride. NaClAq plus AgNO3AQ react to form NaNO3 plus AgCl. Now we check these products with the solubility rules. One of the rules tells us that all group 1A elements make soluble ionic compounds. Sodium is in group 1A, thus it will be soluble. Another rule tells us that nitrates are soluble, and there are no exceptions to this rule. Thus, we can conclude that sodium nitrate does not form a precipitate and remains aqueous. And we place an AQ behind the formula. Next, we check the other product, silver chloride. One rule informs us that chlorides are soluble, except in the case of the following ions: copper 1 ions, silver ions, gold ions, mercury 1 ions, and lead 2 ions. Since silver ions are one of these exceptions, we now know that silver chloride will be insoluble in water and forms a precipitate. So we can place an S behind the formula to indicate that a solid forms. This equation is called a molecular equation, which is not a very good name because ionic compounds, not molecules, are reacting. To review. First, write the formulas for the reactants. Second, predict what the products will be. Third, check the solubility rules to determine whether a precipitate forms. If one or both products is insoluble, then a precipitate formed. Proceed to write the equation, check to make sure that the correct phases follow the formulas and it is balanced correctly. If both of your products are soluble, then no precipitate formed. Simply write no reaction following the arrow.